And the current question is coming from paper number 2, where we were having MCQs questions, and in MCQs we are having one single correct and more than one correct. The present question is from single correct options. Straightforward, that objective question where only one option is correct. Here is the question. This question is about EAS reactions of benzene, and more specifically we are talking about the Friedel-Crafts reaction. So the question was, you are starting with the benzene and we are getting 3-isopropyl N-propyl benzene. So we have these different options available. First one is Friedel-Crafts alkylation. We are doing first, then reduction, then alkylation. There is no point of doing a reduction in the Friedel-Crafts alkylation. Benzene ring may be getting converted into cyclohexane. That kind of reduction we may not be requiring. And in the first place, if you do alkylation, basically if in the first step you are getting something like this, then this is becoming ortho and para directing. The next group will be appearing either under these positions, either ortho or para. But our given question is not about that. This given question is synthesizing meta. So first option cannot be correct, and this third option also cannot be correct. These two are going to be incorrect options. Now we are comparing B and D one by one. In option number B, if you are going ahead, first you do acylation. That is a good choice. But if you have done acylations, you are doing reduction of the side chain, again you are doing something which is similar to what was in the previous step. This is again going to be ortho and para directing. The further attack is going to happen here, so this is also not a possibility. The only possibility over here we are having is the option number D, where we should be doing first of all Friedel-Crafts acylation. Acylation we are doing first, and then we are doing Friedel-Crafts alkylation the very next step, because this was meta directing over here. So when we have done acylation, so basically in that same thing, if you are starting from Friedel-Crafts acylation, now rather than doing reduction which we have done in the option number B, we should be doing another alkylation onto the benzene ring. So this COR group is there because this was meta directing, and here we can get now the alkyl group attached. And in the subsequent step, now if you are doing reduction, H if you are putting in the subsequent step, the COR group will be converting into CH2R. That is how we can be going ahead with the synthesis. That is how meta compound can be synthesized. So this question was about that. Here there is one small point which students, when they are in a hurry, they may not realize what they have done. Although seeing the question, there is only one option which can be working. Talking about the practical situation when we are actually synthesizing these kind of alkyl benzenes or aromatic hydrocarbons, we are planning some reactions which are giving us better yields. And we have learned that when we are having strong electron withdrawing groups like nitro, cyano, benzoic, carbonyl groups, benzene is very much deactivated because it is very electron poor. Attack of this very poor electron ring onto electrophiles like carbocation, which are not very strong electrophiles, is not very easy. So that reaction suffers in the terms of yield. The yields are going to be very poor. Unless and until we are having some very strong source of electrophile, that kind of reaction, this reaction will be suffering too much in the terms of yields, because strong electron withdrawing group which was present in this is not having very much electron density over the ring. So this electron poor ring is not able to attack onto the electrophile very easily unless and until we are going to keep the concentration of R plus very high. So question wise, we are going ahead with the option number D. That is the correct choice. But there is one point what we should be always keeping in mind, that strongly electron withdrawing groups are not very much reactive. So those reactions will be suffering in the terms of yields. So practically at the practical level, when we are synthesizing, we should be modifying our reaction rather than simple Friedel-Crafts alkylation using AlCl3 to something else. So the very first step what we have done is, as expected, we are doing acylation. Over here we are going to do the reaction with the N-propyonyl chloride. So that carbocation which is going to be generated, CH3 CH2 C double bond O, this would be attacking onto our benzene ring, and we'll be getting this propionyl benzene generated. This propionyl group on the benzene ring is meta-directing, and the ring has become deactivated because of its electron withdrawing nature. Now, for the next step, we have to devise something where our electrophile can easily attack. We may need to have quite high concentration of the carbocation, which is the electrophile. So if H+ ion is reacting with this alkene, we could be getting CH3, CH+, CH3, this kind of carbocation we can get. But in order to keep the concentration of this carbocation very, very high, we are using something which is giving us very, very high concentration of H+ ions, that is HCl plus AlCl3. This compound is going to give us the activity of H+ ions very, very high, which is a kind of superacid, although in the terms of superacids we have been using HCl plus SbCl5 in most of the places. But HCl plus AlCl3, because Cl goes with the aluminum, so the H+ ions concentration can be very easily available in the reaction medium, and then H+ ions can be attacking onto the alkene very, very easily. So the point over here was that AlCl3 is not generating the carbocation coming from the reaction of alkyl halide. It is now behaving as a very, very strong acid, and that acid is giving you very high concentration of electrophile, that is isopropyl carbocation, and now that reaction can be giving us very good yield, so that we can get isopropyl onto the meta position as per the directive influence of the propionyl group present on the benzene. We should not be using these kind of reagents for the reason that the concentration of the electrophile which is coming in these reactions may not be very, very high. Our reaction may be suffering in the terms of yield. And in the last step, what we are doing is we are converting this CO group into CH2 group back. We can be using either Clemmenschen reduction, this one, or we can be using Wolff-Kishner reduction, and we can be getting the final products. So that was a very interesting question to check the conceptual understanding of the students, how you can get two alkyl groups onto the benzene ring, and these two if they are at the meta position. Okay, so that's all in this question. I hope you understood the concepts and the minute points which might have slipped when you are solving this question for the very first time. Seeing the options, you can surely reach very easily to the option number D, but you should also keep in mind that the second step when you are doing Friedel-Crafts alkylation may not be very, very good thing to do. You may be suffering in the terms of yield. That's all for now. Thank you. Bye bye. See you next time.